Jai Hind to all of you. I am Updesh Kumar Jaiswal, working as assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to deliver a lecture on topic object-oriented analysis, object-oriented design and object-oriented programming. This topic is related to subject object-oriented programming of the AKGEC and the subject code is the KOE064. Firstly, I want to introduce what is object-oriented analysis. Object-oriented analysis is the procedure of identifying software engineering requirements and developing software specifications in terms of a software system's object model which consists of interacting objects. The main difference between object-oriented analysis and other form of analysis that in object-oriented approach requirements are organized around the objects which integrate both data and function. But in traditional analysis, both function and data are considered separately. The primary tasks in object-oriented analysis are, the first task is the identifying the objects, organizing the objects by creating object model diagram. This is the second task. Defining the internals of the object, that is the object attributes. This is the third task. Defining the behavior of the object, that is called as the object actions, and this is the fourth task. And describing how the objects interact. So basically, object-oriented analysis is the first technical activity performed as a part of object-oriented software engineering. Object-oriented analysis introduces new concept to investigate a problem. It is based in a set of basic principles which are as follow. There are some basic principles. The first principle is the information domain is model. The second principle is behavior is represented. And third principle is function is described. Data, functional and behavior models are divided to uncover greater detail. Early models represent the essence of the problem, while later ones provide implementation details. Here I am showing a table which is representing the advantages and disadvantages of object-oriented analysis. In case of advantages, object-oriented analysis, in short OOA, focuses on data rather than the procedure as in structure analysis. The disadvantage is the functionality is restricted within objects. This may pose a problem for systems which are procedural or computational in nature. Next advantage is the principle of encapsulation and data hiding help the developer to develop system that cannot be tampered by other parts of the system. In case of disadvantage, it cannot identify which objects would generate an optimal system design. The next advantage is the principle of management of software complexity to be virtual modularity. All the interfaces between the object cannot be represented in a single diagram. It can be upgraded from small to large system at a greater ease than in a system following structure analysis. This is the one of the advantages of object-oriented analysis. Now, the next term is object-oriented design. According to the Grady Booth has defined the object-oriented design as a method of design involving the process of object-oriented decomposition and a notation for presenting both logical and physical as well as static and dynamic model of the system under design. Object-oriented design mainly involves implementation of the conceptual model procedure during object-oriented analysis. The implementation details generally include, in case of object-oriented design, the following implementation details are included: restructuring the class data if necessary, implementation of methods, that is internal data structure and algorithms, implementation of control, and implementation of association, one to one, one to many, many to one, like that. After the analysis phase, the conceptual model is developed further into an object oriented model using object oriented design. In object oriented design, short OOD, the technology independent concept in the analysis model are mapped onto implementing classes, constraints are identified, and interfaces are designed, resulting in a model for the solution domain. In a nutshell, a detailed description is constructed specifying how the system is to be built on concrete technology. The stages for object oriented design can be identified as, we can identify the stages in case of object oriented design by definition of the context of the system. This is the first method to identify. Designing system architecture, identification of the object in the system, construction of design models, and specification of object interfaces. So now I am going to discuss about what are the different steps in object oriented design. Mainly there are 4 stages in case of object oriented design. The first stage is the subsystem design, then class and object design, then message design, and finally responsibility design. These are the object oriented design pyramid. So the subsystem layer, it represents the subsystem that enables software to achieve user requirements and implement technical framework that meet user needs. The class and object layer, it represents the class hierarchy that enable the system to develop using generalization and specialization. This layer also represents each object. The third layer is the message design layer. It represents the design details that enable each object to communicate with its partners. It generates the internal and external interfaces for the system. Now last step is responsibility layer. It represents the data structure and algorithm designed for all the attributes and operation for each object. Now a very important term, that is the object oriented programming. Object oriented programming is a programming paradigm, is a programming style based upon objects that aims to incorporate the advantages of modularity and reusability. Two terms are very important, two features are very important, that is the modularity and reusability. Objects which are usually instance of a class are used to interact with one another to design application and computer programs. The important features of object oriented programming are, the first important feature is it is a bottom up approach in program design. The second feature is programs organized around objects grouped in classes. The third important feature is focus on data with method to operate upon objects data. The fourth method is interaction between objects through function, and reusability of design through creation of new classes by adding features to existing classes, and we can achieve by using the inheritance. Modularity is also important. Some examples of the object oriented programming language are C++, Java, Smalltalk, Delphi, Perl, Python, Ruby, and PHP. These are the famous programming language all over the world which are based on the object oriented programming. Now object oriented programming style. Object oriented programming style is a technique of a computer programming that represents concept as objects that have unique attributes and behavior. This style has 3 important properties which are discussed below. Reusability, it means using the same code again and again without writing in twice. It is a concept of object-oriented programming that is achieved via inheritance. Inheritance is used, it provides the reusability, it helps to save money, memory and reduce the complexity of the program. With the use of reusability, we can add additional feature to an existing class without modifying it. And it is achieved by the inheritance. It can be achieved by the method overriding also. The second important property is extensibility. In object-oriented programming refers to the design principle that allows a software system to be easily extended or enhanced with new features, functionality or components without requiring significant modification to the existing code. Robustness is the capable of handling unexpected inputs that are not explicitly defined for the application. Robustness is the capacity of a computer program to handle the errors during execution and manage the incorrect input of data. So we can say C++ is a robust programming language. Now, the next important topic related to this is structure analysis and structure design. In short, it is called as the SASD. Structure analysis and structure design is a diagrammatic notation that is designed to help people understand the system. The basic goal of SASD is to improve quality and reduce the risk of system failure. A risk is a potential danger that can be occurs, that cannot be occurs. But if it occurs, then it creates the problems in the development of the software system. So quality can be improved and risk can be minimized by using the structure analysis and structure design. It is a concrete management specification and documentation. It focuses on the solidity, maintainability of the software system. Structure analysis and structure design is a software development method that was popular in 1980 to 1990. The method is based on 1990. The method is based on the principle of structure programming, which focuses on the importance of the breaking down a software system into smaller, more manageable components. In SASD, the software development process is divided into two phases. In case of structure analysis and structure design, the software development process, the software development phases are divided into two parts, that is the structure analysis and structure design. During the structure analysis phase, the problem to be solved is analyzed and the requirements are gathered. After gathering the requirement, the problems are analyzed. The structure design phase involves designing of the system to meet the customer requirement that were gathered in the structure analysis phase. SASD is a traditional software development methodology that was popular in 1980 to 1990, I already told. It involves a series of techniques for designing and developing software system in a structured and systematic way. Here, I am giving some key concept of SASD. I am going to discuss about some key concept that is used in the case of SASD. The first key concept is functional decomposition. As we know about the functional decomposition, SASD uses functional decomposition to break down a complex system into the smaller, more manageable such system. We are dividing the whole project into the small part. We are dividing the complete system into the small part, that is the subsystem. We can say modularity. This technique involves identifying the main function of the system and breaking them down into the smaller function that can be implemented independently. Now the subsystem are independent, they are not dependent on other. So we can say they have higher cohesion and low coupling. Now data flow diagram, we are already familiar with the data flow diagram. SASD uses data flow diagram to model the flow of data through the system. Data flow diagrams are graphical representation of system that show how data moves between the system various components, how the data is moves along the various component of the system. Next, data dictionary. We are also familiar with this. A data dictionary is a central repository that contains description of all data elements used in the system. It provides a clear and consistent definition of data elements, making it easier to understand how the system works. Now, structure design. SASD uses structure design techniques to develop the system architecture and components involved identifying the major component of the system, designing the interfaces between them, and specifying the data structure and an algorithm that will be used to implement the system. Now, modular programming. SASD uses modular programming techniques to break down the system's code into smaller, more manageable modules. This makes it easier to develop, test, and maintain the system. If you are dividing the complete project into the small modules, then it will be very easy to develop the system, to test the system, and maintain the system, because they are independent to each other. Structure analysis and structure design has two phases. The first phase is analysis phase and second phase is the design phase. In case of analysis phase, we are using the data flow diagram, data dictionary, state transition diagram, and ER diagram. You are familiar with this diagram and we know how we can draw this diagram. It uses a structure chart and pseudocode. This is the design phase. Advantages of structure analysis and structure design. The first advantage is the clarity and simplicity. The SASD method focuses on the breaking down the complex system into the smaller, more manageable components, which make the system easier to understand and manage. So we can say clarity and simplicity is improved. Better communication. The SASD method provides a common language and framework for communicating the design of a system, which can improve communication between stakeholders and help ensure that the system meets their needs and expectations. You are familiar with the stakeholder, the person who have interest in the software development, they are called as the stakeholder, like developer, tester, shareholder. Improve maintainability. The SASD method provides a clear, organized structure for a system, which can make it easier to maintain and update the system over time. So maintainability is improved. Better testability. The SASD method provides a clear definition of the input and output of a system, which makes it easier to test the system and ensure that it meets the requirement of the customer and developing the good quality projects. Now, relationship between object model, dynamic model, and functional model. These are interrelated to each other, and we can combine these three models in case of object oriented programming. The first model that is combined is the object modeling. The process of object modeling can be visualized in the following steps. Identify object and group into classes, identifying the relationship among the classes, create user object model diagram, define user object attributes, define the operation that should be performed in the classes, and review glossary. Now, dynamic modeling. The process of dynamic modeling can be visualized in the following steps. Identify state of each object, identify events and analyze the applicability of actions, construct dynamic model diagram containing the state transition diagram, express each state in terms of object attributes, and validate the state transition diagram drawn. In case of functional modeling, the process of functional modeling can be summarized in the following steps. Identify all the input and outputs, construct data flow diagram showing functional dependencies, state the purpose of each function, identify constraint, specify optimization criteria. Now, Jackson System Development. In short, it is called as the JSD, which is used in the software engineering. So, JSD is the method of system development that covers the software life cycle either directly or providing the framework into which more specialized techniques can fit. JSD can start from the stage in a project when there is only a general statement of the requirements. However, many projects that have used JSD actually started slightly later in the life cycle, doing the first stage largely from existing documents rather than directly with the users. The main phases of JSD are modeling phase, specification phase and implementation phase. In the modeling phase of the JSD, the designer creates a collection of entity structure diagrams and identifies the entity in the system, the action they perform, the attributes of the action and the time ordering of the action in the life of the entities. Specification phase, this phase focuses on actually what is to be done. Previous phase provides the basic for this phase. Implementation phase, third phase is the implementation phase. In the implementation phase, JSD determines how to obtain the required functionality. Implementation way of the system is based on the transformation of specification into efficient set of processes. Now, the main steps involved in the JSD, Jackson system development, are: initially there were 6 steps when it was originally presented by Jackson. They were given below. Entity action step, second is initial model step, third is interactive function step, fourth is information function step, system timing step, system implementation step, and in the later 3 more steps are added, that is the modeling step, network step and implementation step. Benefits and limitation of JSD. What are the merits and demerits? I am going to discuss about this. The main benefit of JSD is it is designed to solve the real time problem. JSD modeling focuses on time. It considers simultaneous processing and timing. It is a better approach for microcode application. No system can be 100% perfect, so there should be some demerits also. The first drawback is it is a poor methodology for high level analysis and database design. JSD is a complex methodology due to pseudocode representation. It is less graphically oriented as compared to SASD or OMT. It is a bit complex and difficult to understand. Now I am going to show how we can translate a class into a data structure. Here I have taken example of a class and the name of the class is circle, and in this class, by using the concept of encapsulation, 3 data members are present with the name S code, Y code and radius, and 3 member functions are also present: find area, find circumferences and scale. Now the following figures show the representation of the class circle using the C++ code. Here I am writing a code in C++ for this diagram. Here circle is the name of the class and class keyword is used before this to define that is the data structure of type class. In the private field, I have taken 2 variables with name S coordinate and Y coordinate, in short S coord, Y coordinate, and it is of the double type. This is the data type. In the protected field, I have taken 3rd variable that is called as the radius and it is of the double type. In the public field, 3 member functions are defined: find area, find circumference, scale. These 2 functions are returning the value of double type. So here I am translating the class into the data structure. These are the references which I have used to making this lecture. Thank you very much. Jai Hind to all.